Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed rearrangement of spirocyclohexadienins, diene-1-phenol rearrangement. Moving on to the next step. The compound is spiro 4.5 deca 6,9 dien 8-1, which is a cyclopentane ring joined at a spirocarbon to a 2,5-cyclohexadiene 1-1 paraquinol type. The spirocarbon is at C1 of cyclopentane and C1 of the cyclohexadiene. Moving on to the next step. Acid-catalyzed mechanism, diene-1-phenol rearrangement with ring expansion under H+ conditions. The carbonyl is protonated, generating a carbocation at the carbonyl carbon. A1, 2-carbon shift migration of one of the C to C bonds of the cyclopentane ring to the adjacent carbocation center occurs. This is the classic spiro-diene-1 rearrangement. And for the final step, the cyclopentane C to C bond migrates into the 6-membered ring. This converts the 5-membered ring plus 6-membered ring spiro system into a fused bicyclic system. The migration of a cyclopentane carbon into the ring expands the cyclopentane to become part of a 6-membered ring, giving a bicyclo 4.4.0 decalin type framework with an aromatic ring after tautomerization aromatization. After the 1,2 shift and rearrangement, the product is a bicyclic compound where the 6-membered diene-1 ring has aromatized to a phenol ring, or on the ring, and the cyclopentane has ring expanded to a fused cyclohexane ring. This gives 5, 6, 7, 8 tetrahydro 2-naphthyl or equivalently octahydronaphthalene with an O on the aromatic ring, which matches option B, a naphthalene skeleton with one aromatic ring bearing HO and one saturated cyclohexane ring fused to it. Option A, O at C1, ring junction, non-aromatic, does not arise. Aromatization drives the O onto the ring as a phenol. Option C4, cyclopentyl phenol would require ring opening rather than ring expansion, not the major pathway under these conditions. Option D, the cyclohexadienol, non-aromatic, form is not the final product. Aromatization to phenol is thermodynamically favored. Therefore, the correct answer is B. Therefore, the correct answer is option B.